Hello everyone, we are Jinghe Technology. This video primarily demonstrates how to program a screw tightening machine. Should you be interested in learning more about this machine, please feel free to contact us at any time. Contact details: www.jhims.com. When the machine is in operation, it is strictly forbidden to insert any part of the body into the working area. Should any operation be required, first bring the machine to a complete stop before proceedings. Methods for connecting cables. This is the signal cable. There are 4 holes. The other 2 signal lines, the number of holes is 2 and 3. This is 4 whole digits, so they cannot be used interchangeably. Upon receiving the machine, locate the corresponding socket for connection based on the number of holes in the cable. This cable has 3 hole counts and has positioning slots on it. The cable below is the number of 2 holes. Therefore, signal lines cannot be connected interchangeably. So this is a 220 volt, 2 kilowatts power cord. This is the feeder signal line. This is the intake pipe for air. This is an air switch. Pushing and pulling can turn the air on and off. Air working pressure is 0.5 to 0.6 megapascal. These tracheas will be delivered with the machine. We will prepare all the parts of the machine. This is the controller of the screw vibrating feeder. Do not modify the parameters after they are set. These 2 are the signal lines of the screw vibrating feeder. We can unplug the signal cable by pressing the switch below. Suppose we pull out a signal wire, the vibrating plate is not controlled, and the feed will vibrate continuously. You see, in the constant vibration. The debugging method of the vibrating feeder should ensure that the screws are continuously fed one after another. We open the gland, it should be full of screws underneath. You see the shaking state of the screw. The screw is only slightly shaking. The screw should not shake too much. The debugging method of the controller, and the U is for voltage. Just set this voltage within 100. If the voltage is too high, the screw will shake very severely. You see, the voltage is very high now and the jitter is very serious. The voltage is controlled within 100. Click to adjust the frequency of vibration. Left to right is to adjust the frequency. You see, the movement speed will be faster. The speed of the screw can be just as long as it can meet the feeding speed. This speed can meet the feeder. The adjustment method is to meet the speed of the feeder and minimize the jitter. Now the frequency is 238.5, which is a good effect. After the parameters are adjusted, don't modify them at will. If there are other screws, you may need to fine-tune them. Fine-tune this frequency. We mainly adjust the voltage and frequency, requiring the lower the vibration and the faster the speed. If we replace the screws with other sizes, we only need to make fine adjustments. It's not that the faster the better, as long as we can meet the feeding speed, it's fine. You can debug according to the voltage and frequency in the video. The screws on this guide rail should not vibrate too much, and the screws should not be stacked. If the screws are moved left and right and stacked, the frequency should be reduced. This state of the vibrating feeder is almost enough. Ensure that the screws can meet the feeding speed. The voltage is between 80 and 90, and the frequency is around 238. After the vibrating feeder is properly debugged, we insert this signal cable. The first one is brown, and the second one is blue. It has labels, 1 on the left and 2 on the right. Other parameter settings of the vibrator. This U is voltage. Click to switch to frequency. Mainly adjust the voltage and frequency. Long press this, then rotate, switch BF. This is the delay. We usually set it to 0.4 seconds. If you set 1, it will vibrate continuously. Normally, just set a delay of 0.4, then click it again and it will be set successfully. Long press to exit. Suppose I want to lock this parameter and prevent modification. You have to long press for more than 3 seconds to achieve this function. It cannot be modified. Lock and unlock operations are the same. You have to long press for more than 3 seconds. Cancel this red light. It unlocks. We introduce the connection methods of these cables and trachea. Let's take a look at this trachea and how it is connected. The trachea will be connected to these 3 vacancies. The trachea is connected to this location. Then these 3 signal wires will be unplugged. These sockets were introduced earlier, just connecting them to each other. The other port of the trachea is divided into 2 trachea. These are the 3 signal lines just now. This wire is the 3 wires connected to the machine. This is the press cover for the screws. This is called a screw track. The ones on the left and right are the little tracks. It's called a putter. This putter and small track are wearing parts. How to determine whether the installation method of this part is correct? Under normal circumstances, from the track to the small track to the push rod is a straight line. Let's zoom in. The 3 parts should form a straight line. If the small track clearance is too large, the screws will fall off. If the gap adjustment is too narrow, the screws cannot pass through. Make sure the width is the same and the height is the same. Finally, like a straight line. This is the putter. This one moves left and right. This one will wear out after a long time, and if there is a gap, it needs to be replaced. If this push rod moves to the left, the screw will fall into the trachea and be blown into the working head to assemble the screw. Because this push rod pushes the screw to the left into the trachea, there will be wear and tear if it often moves left and right. We should pay attention to check this. If there is a card phenomenon when the screw is fed, it is necessary to replace or debug this part. Let's introduce the working head module. This is a depth sensor. If it is to assemble the LED module plastic base, this depth sensor is not required. We don't want this to sense the depth sensor. Tighten this small screw. Generally, when assembling LED module masks, depth sensors are required. This is the locking cylinder. And then this is the screw sensor. When the screw passes through the sensor light turns red. Red light flashes. This is a Vision CCD camera. Before the machine leaves the factory, the coordinate position of the CCD camera and the screw nozzle has been corrected. This is a servo motor. If you adjust the torque of the screw tightening, we will set it in this operating handle. This is the operating handle of the machine. Next, we will explain how to write a program. Today's video ends here. I hope you can like and subscribe. If you don't understand, please contact us. JHIMS.com.